prism. In our previous video, we figured out how to determine the number of faces, the number of vertices, and the number of edges of a triangular prism, of which, after our deduction, we saw that the faces of a triangular prism were 5, the vertices of the triangular prism 6, and we had the edges of the triangular prism to be what? 9. Today's video, we really want to talk about how to derive the formula for the total surface area, the curved surface area, and also the volume for a triangular prism. So considering this shape to be the triangular prism, this is going to be the net of this triangular prism, and precisely the shape here, it is a right triangular prism, right? So this is a right triangular prism. It is a right triangular prism because the right angle we have over here is what? A right triangle, right? So the net is going to help us to figure out the formula for the total surface area of this triangular prism. So if, considering this triangular prism, this is my height, so in the net, this vertical, line is going to be the height, and this triangle is similar to this triangle, so here it is going to be the height, and my base of the triangle is going to be here. This is going to be my base, it is going to be base, and then this side is A. It's going to be the same as here, so the distance from here to here is going to be A. The distance from here to here is going to be A because this side is similar to what? This side of the triangle. It is this side. This side is going to be the same as this side. We open it up together, right? So this side will be the same as this side. So if here to here is H, here to here is going to be H, and then this side is going to be the same as what? This side. So if here's A, here's 2 is going to be 1, A, and this is going to be the length, and that length is going to be here, right? Yeah. So here's L. Okay. Now to find the total surface area, we have an acronym for the total surface area. So the T stands for the total, the S stands for the surface, and the A stands for what? The area. So we normally say the TSA, which means the total surface area, right? So to find the total surface area of this shape, we have to consider the area of all the faces, right? Then we add them. Now, looking at this, you can see that since here is H and here is L, right? These three shapes, they are quadrilaterals. And then the formula for finding the area of quadrilateral, for instance, a rectangle, right, is gonna be the length times the what? The height that we have over here, isn't it? So the area of this rectangle is going to be length times what? Height. Good. So considering this rectangle, the area of this rectangle, here's L and here's H, right? It's going to be LH, right? Plus the next one, okay? So first, the area of this is for LH. And then also, we're going to consider the area of what? This, quadrilateral. The area of this is going to be, VL, right? This side, B times this, which is 1L. Here is the same as here. So that is LB plus, this quadrilateral, this one. Okay, and the area of that is going to be what? L times what? The A, that plus, that's the LA is for this, LB is for this, then the LA is for this one, the area of this, right? Now it's left with the area of the triangles, but we say the triangles are similar, and the formula for determining the area of a triangle is what? Half base times height. And because it is a right triangle, I need to indicate the angle between this line and that line. They are perpendicular, right? Meaning the angle between them is 90 degrees. So this is going to be my base, and since this line is perpendicular bisected to this line, or perpendicular to this line, then this is going to be my height, right? So it's going to be half base times what? Height. Base times height. And this triangle is similar to this. The area of that is going to be the same, which is half base times what? Height. Now from these three terms, 1, 2, 3, right? The area of 1, 2, 3, you can see that L is common in these three terms, right? The first three terms. So we can factorize the L out, and when we factorize the L out, this term is going to be left with what? H, plus the next term, when the L is out, is going to be left with what? B, plus when the L is out, this term is going to be left with what? A, then plus half BH plus half BH. Half plus half is going to give us what? 1. So half BH plus half BH is what? BH, right? Good. Now, the next thing we're going to do is we're going to say let P be equal to H plus B plus what? A. So the variables that are within this bracket, we want to let them be represented by a single one variable, that is P, okay, or a single alphabet, that is P. Then in place of H, B plus A, we can write what? P, L, right, plus what? B, H, right? And look at the triangle HBA. What's HBA? HBA is the perimeter of what? The triangle. So the P here means that we are talking about the perimeter of the right triangle in our what? In our triangular prism times the length, right? So that is the PL. And after that, we add the area of the what? The triangle. But the triangles are two, and one of them is half base times height. But since there are two, then half base times height plus half base times height is going to be what? BH. And therefore, this one gives us the formula for the total surface area of a what? A triangular prism. Okay, that's the total surface area of a triangular prism. Now, having gotten the total surface area of a triangular prism, our next thing is we're going to look at how to determine the formula for the curved surface area. And the acronym for the curved surface area is CSA, okay, curved surface area. And to talking about the curved surface area of the triangular prism, this is situation where, or maybe talking about the curved surface area of any 3D shape at all, it's a situation where the bottom and the top is being removed from the shape that we're considering. Since we're talking about a triangular prism, then the curved surface area is when we take, the triangle at the bottom and the triangle at the what? Top from the shape. And when that happens, since both triangles are being taken from the shape, the area of the two triangles give us what? The BH in its total surface area. So in a curved surface area, if the two triangles are being removed, then you realize that the surface area that is going to be left is going to be what? PL. So in a curved surface area, we're not going to be having this triangle, we're not going to be having what? This triangle, and our surface area is going to be P1L. Why? Because the two triangles gave us the BH. And when they are removed, then they will give me what? BH. Here is going to be 0. And PL plus 0 is what? 0. 0 is insignificant, and there's no need to write it. Therefore, the CSA of a triangular prism, or the curved surface area of a triangular prism, is what? PL. Now, please, you do remember that we said the P is the what? The perimeter of the triangle, right? The P stands for the height of the triangle, the base of the triangle, and then what? Since it's a right triangle, we can say this side is the what? The hypotenuse of that triangle, right? Good. Now, the last thing I want to talk about is the volume of the triangular prism. And the formula for the volume of the triangular prism is going to be, half, the area of a triangle is half base times height, right? But since we're talking about the volume, we need to multiply this by what? The length, okay? And you find half base times height of the triangle times the length to obtain the what? The volume. So the volume is going to be half base times height times what? Length. Now, considering the volume, we have to know that volume is measured in cube units, right? Where the area or the surface area, the unit of the area should be in what? Square units. So that is the only probably key point that I will want you to take note. If you're calculating the volume, your unit should be in cube units, right? And then the surface area, it should be square units. If you find this video interesting, please subscribe to the channel for more research. Thank you. See you when I see you.